In this session, let us understand multidimensional arrays. Multidimensional arrays can be considered as an array of arrays. The data in multidimensional array is stored in a tabular form. That means every element in the multidimensional array will be represented using multiple subscripts. Now, let us see the general form of declaring n-dimensional array. So, the syntax for declaring an n-dimensional array is given as data type, array name, size 1, size 2, etc. size n. So, here data type is to be specified, that is what are the type of elements in the array. Then array name represents the name of the array. Size 1, size 2, etc. size n represents the dimension of the array. So, every array that is having more than one subscript will be considered as multi-dimensional array. So, we have already seen about one-dimensional array. So, one-dimensional array can be declared using the data type, array name and size of the array. So, here you can see an example for one-dimensional array. So, this is a one-dimensional array. Here you have specified a data type, name of the array. Your name of the array is A and the maximum size of the array is 5. It means that 5 elements can be stored in the array at a maximum. So, here you can see that here there is only one subscript. And if there is more than one subscript, then it belongs to the category of multidimensional array. So, it can be 2, it can be 3 or any number of subscripts. So, in general, we can say that there are n subscripts, then it is more precisely known as n-dimensional array. If the number of subscripts is 2, then it can be called as two-dimensional array. If the number of dimensions or subscripts is 3, then it can be called as three-dimensional array. So, in general, if there are n subscripts, then it will be an n-dimensional array. So, all these arrays, two-dimensional, three-dimensional, etc. n-dimensional are generally called as multidimensional array. Now, let us see some examples. So, here is an example for two-dimensional array. Int AR1 10 20. So, here clearly there are two subscripts. First subscript is 10 and second subscript is 20. So, this is a two-dimensional array. And if you have three different subscripts, then it will be a three-dimensional array. So, here AR2 is a three-dimensional array, which is having three different sizes, size 1, size 2 and size 3. So, this is how multidimensional arrays are declared. Now, let us see what is the size of multidimensional arrays. How to find the total number of elements that can be stored in a multidimensional array. So, this can be found by multiplying the sizes of all the dimensions. So, if you have 2 dimensions, then multiply the 2 sizes and what will be the result of that multiplication? Then it will be the total number of elements that can be stored in the two-dimensional array. So, let us see an example here. So, here we have defined a two-dimensional array X of integer type and with subscripts 10 and 20. So, just by multiplying 10 and 20, you will get some result and this result will specify the number of elements that can be stored in this particular array. So, you can take another example here. Let it be int A of, let us say this is a three-dimensional array and it consists of 3 different dimensions. So, let it be 5, 3 and 2. So, here we have 3 subscripts, therefore, this is a three-dimensional array and the total number of elements that can be stored in this particular array can be found by multiplying all these sizes. 5 into 3 into 2, which gives 15 into 2, that is 30. Maximum number of elements that can be stored in array A is 30 elements. So this is how we can find the total number of elements that can be stored in a multidimensional array. Now, in this session, we will discuss in detail about two-dimensional arrays only. So what is a two-dimensional array? An array which is having two subscripts can be considered as two-dimensional array. So this can be organized as a matrix. A matrix will be having rows and columns. So it can be said as a collection of rows and columns. So this is how a two-dimensional array can be declared. That is data type, array name, then two dimensions are specified as maximum rows and maximum columns. So the first subscript always represents the number of rows in the matrix, and second subscript always represents the maximum number of columns in the array. So this order is to be maintained. First subscript represents the row number and second subscript represents the column number. So let us see an example here. Int x of 3, 4. So here 3 represents the number of rows in this array and 4 represents the number of columns in the array. So in a user's view, this can appear as a matrix which is having 3 rows and 4 columns. So the first row will be having 4 different elements. Second row will also be having 4 different elements, and third row will contain 4 different elements. So this is how this array looks like. So this is a 3 by 4 matrix. So 3 by 4 matrix will be having maximum 12 different elements in it. So you can see how it appears. So this is how 3 by 4 matrix appears to a user. So there are 4 different columns in it and 3 different rows in it. The first row will be containing 4 different elements, and each of these elements can be accessed or represented using the subscripts. First subscript represents the row number and second subscript represents the column number. So here always the index begins at the value 0, similar to one-dimensional arrays. So the first element will be represented using subscripts 0, 0. X of 0, 0 will be the first element in this array. And now let us see how to access the data in a two-dimensional array. So the elements of two-dimensional arrays are always accessed randomly by using the subscript. So the subscript represents the row index and column index of the array. And if you know the row index and column index, a particular element in the array can be accessed. In general, the array index values are represented using Aij. If A is the array name and then I represents row index and J represents the column index of the array. So if you want to find an element, say for example, let us take this example. So here if you want to find the element at, let us say this array is taken as X. So if you want to find an array 2, 0. So here in general you are taking this as X of I, J. So I value will be 2 and J value will be 0 here. So I represents the row index. Here I is 2, therefore will be in the third row. Since it is beginning at 0, first row is represented using 0 index, second row is represented using the index 1, and third row will be represented using the index 2. So row 3 will be represented by using index 3. Sorry, 2. So here I value is 2 and J value is 0. So it represents this particular element. So this element can be accessed using the subscript 2 and 0. So this is how you can access the array, that array element in a two-dimensional array. Now, let us see how to initialize two-dimensional arrays. So, initialization of two-dimensional arrays can be performed in two different ways. So, the first method is that here it is shown here, that is int x of 3, 4 is equal to, we have given some elements here and the values of the array will be represented using these elements. So, let us see what it represents. X 3 by 4, that is, there are, so the first subscript represents the row numbers and second subscript represents the maximum number of columns. So, here you have 3 rows and 4 columns and total number of elements in this array will be 3 into 4, that is 12. 12 elements will be present in this particular array. And how these elements are initialized? All the elements are included in a pair of braces which are separated by commas. And in order to distinguish it from the different rows, we can say there are 3 different rows and 4 different columns. So, the first 4 elements will be belonging to the first row 1. The next 4 elements will be belonging to second row and the next 4 elements will be in, here the first row elements will end here, second row elements will end here and the third row elements will be 8, 9 and 8, 9, 10 and 11. So, the third row elements will be these 4 elements. Okay, so this is how the first method of initialization works. Then comes the second method. This is a more efficient method. You can identify each and every row separately in this method. So, here the array declaration takes the form x of 3, 4 is equal to, it is specified in a pair of braces and every row will be again included in an inner pair of braces. So, the first row elements will be represented in a pair of braces, then the second row elements will be represented in another pair of braces and third row elements will be represented in another pair of braces. So, each of these rows will be separated by using inner braces. So, this is a more efficient method for identification. So, now comes how to store elements in a matrix and printing it. You can see a program here. So, how to store a matrix. Since it contains 2 different subscripts and one subscript represents the number of rows and second subscript represents the number of columns in it, we have to use 2 different loops. So, in one-dimensional array, in order to store and print values, you have used one for loop. Here, you have to use 2 different for loops in order to store and print matrix. Now, you can see first of all, we have to declare the array. So, here you have declared a two-dimensional array ARR with 3 rows and 3 columns. So, here you have declared a 3 by 3 matrix and ij values are used to access the row index and column index. Now, you have to declare the define the for loop for accessing the row. So, the first for loop represents the row and second for loop is for representing the columns. So, here you have to enter all the elements in the array. So, here you can input the values of the array elements using the scanf function. So, when this for loop, these 2 for loops work, you can give values to array ARR. Now, we have to print the different values in this array. For printing also, you have to use 2 different for loops and access all the elements in the array by using ARR at I and j. So, during the execution of this program, you will be accessing all the elements in the array and displaying it. So if you want to know the working of this program, you can check it like this. So initially I value is set as 0, and whenever it satisfies the I less than 3 condition, it enters into the inner for loop. Now j value is initialized with 0, and if it satisfies the condition j less than 3, then it enters into the statements printf and scanf. So here you can see enter a of %d I j. So some value will be displayed. Enter a at, so now %d I j value are initialized with 0 and j value is also 0. So you have to enter a value into this array element. Let us enter it as 0. Now again this for loop, inner for loop will be incrementing the value of j by 1. Now j becomes 1. If j becomes 1, the condition is again true, j less than 3. Then the second, this loop will execute for the second time, and you can print the value. Again enter a of %d will be, that is first value, i's value, I value 0 itself. And now comes the j value has changed to 1. Now here you can give another value, let it be 2. And again scanf works, and we have given the value 2. Again j will be incremented by 1. So j will be incremented by 1, and while checking the condition for j less than 3, it satisfies the condition because j is equal to 2 now, and 2 less than 3 is true. Now again this loop will be executed one more time. Then again enter here I value is 0 itself, and j value has incremented by 1. J value is now 2, and we can give another value when this scanf function executes. So let us give the value as 3. So here you have given a02 is equal to 3, and third value is input to the matrix. Again now one more time j will be incremented, and now j becomes 3. And now if you are checking for the condition here, 3 less than 3. So here the condition will be false. Then what happens? See, it will exit from the inner for loop, and it will increment the value of I by 1. Now I value will be incremented, and I becomes 1. I value becomes 1, and 1 is less than 3. Therefore, this satisfies the condition. Again, it will enter into the inner for loop. Now, j is initialized with 0 again. Condition is tested. 0 less than 3, it is true. Then it enters into the statements inside the for loop. And now printf enter %d. This statement will be executed, and the message will be printed as enter a of I value is 1, and j value has been reinitialized with 0. So 1 0 will be printed here. And now the scanf function executes, and you can give a value to this statement here, and you can say next value is 4. So if second row, next row is accessed using A10. So here we are accessing the second row first column element. That will be taken as 4. So this step will be continued until all the elements in this array are input. So here you have input the first row elements. Now you have to execute the same statements similarly, and will be executing the next 3 elements in the second row. Again one more time this for loop will be executed, and the third row elements can be given in order. So all the different elements in the third row can be input using the scanf statement. After inputting all these values, it has to be displayed on the screen. So in order to display it on the screen, again two different for loops are defined, it will also execute in the similar way and displays all the values in a matrix form. So this is how we can store elements in a matrix and print them. Now let us see how to represent a two-dimensional array in memory. So we have seen that we are representing a two-dimensional array in a matrix form. It is only to identify for a user. So from the user's point of view, you can represent a two-dimensional array as a matrix. But in actual memory, it is not stored as a matrix or table form. In actual memory, in a computer memory, the two-dimensional array is stored similar to that of a one-dimensional array. So here you have to map the two-dimensional array into one-dimensional array in memory. So the memory representation can be done in two different ways. We'll see the two different ways here. So before that, let us understand how it appears in user's view. So already we have seen that in user's view, the matrix appears like this. That is, first element is represented by the index of row and column 0, 0. Second element will be represented as 0, 1, 0, 2. So, okay, this will be the user's view for a matrix. Now, when it comes to memory representation can be done using two different techniques. First method is row major ordering. So, the elements in the array will be stored row wise. So, you can see here all the rows in the two-dimensional array are stored into memory in a contiguous manner. So, if you are taking a two-dimensional array, or you can represent it like this in row major order. So, the first row elements are arranged consecutively in the contiguous memory. Then in the next contiguous position, the second row elements will be included. So here all the three elements in the first row are represented. Then comes the second row elements, and after that in the contiguous memory space you will be storing the third row also. So this is how memory representation of two-dimensional array appears in row major ordering. That is, all the rows in a two-dimensional array are stored into memory contiguously. First row will be stored initially, then comes the second row, and then comes the third row. So this is the order of representing elements. So first of all the elements in the first row will be stored in a contiguous memory location. Then the second row elements will be stored in the contiguous locations following the first row elements, and then comes the third row elements. So this is how row major ordering takes place. Next method is column major ordering. According to the column major ordering, all the columns of the two-dimensional array are stored into the memory contiguously. So if you are taking the elements in a elements as column wise, there is first column elements are represented contiguously 0, 0, 1, 0, 2, 0. So here the column values remains constant. That is, first column elements are stored here. Then comes the second column elements 0, 1, 0, 1, 1, 2, 1. Then comes the third column elements. So this is how it appears. First column elements will be stored. Then following that the second column elements will be stored, and following that the third column elements will be stored. So this is the column major ordering. So the memory representation of two-dimensional array can be done either in row major ordering or in column major ordering. Now we will see how to find the address of a particular element in a two-dimensional array. This also involves two methods. If the array elements are stored in a row major order, then the address can be calculated by using the following formula. Address of aij is equal to base address plus I into n plus j into size. Here BA represents the base address, I represents the row index, J represents the column index, and N represents the number of columns. So if we are taking a matrix as A, M, N, M is the number of rows and N is the number of columns. And here in the formula you are using the number of columns for finding the address. So let us take an example here. For example, let's see. If you are having different elements in a two-dimensional array, let's have 4 different elements. First element will be belonging to the index 0, 0. Second element will be at 0, 1. Then third element will be at 0, 2. So if you are taking a 3 by 3 matrix, this will be the arrangement. Then comes the row, this is row major ordering. Therefore, the next element will be from the second row. Second row index will be 1, column number will be 0. Then next element will be 1, 1. Next element will be 1, 2. So this will be followed in order. So these elements are stored in contiguous memory locations, and let the base address of this particular location be 1000. So base address means the address of the first element in the array. So here A of 0, 0 resides at the memory location 1000. And if you know the size of the elements, that is, if you are using a integer array, then to store an integer value needs, let us assume 2 bytes. 2 bytes memory is required for storing. 2 bytes memory is required for storing a single integer value. Then size will be 2 here. Now, in order to find the address of, let us say, if you want to find the address of this particular element, that is A of 1, 0 is to be found, you can apply this formula to find this. So here the address of this particular element will be found by using this formula. Base address will be 1000 here. Base address can be taken as 1000 plus value of I. Value of I is 1 here. 1 into N. N value is, so here you have taken a 3 by 3 matrix. Let us assume that this is a 3 by 3 matrix. We have only given some elements here. So let us assume this M by N value is number of elements, number of rows and number of columns is equal to 3. Then N value will be 3 here plus J. J value is 0 into size of the memory, that is size of one integer will be 2 bytes. So into 2. So the calculating this we will get 1000 plus 1 into 3 plus 0, that is 1 into 3, 3 plus 0, it will become 3 itself. 3 into 2, 6, and the value will give 1006. So the address of this particular location will be 1006. So this is how you can find the address of the element in an array. Now let us move on to the second method. The second method is column major order. So if you are storing the elements in a column major order, then it can be calculated by using the following formula. That is, address of Aij is equal to base address plus j into m plus I into size. If you are taking the same example as before, let us say it is stored in the column major order. So if you are taking a smaller array, let us take an array of 2 by 2 matrix. Let us take a 2 by 2 matrix here. That is the total number of elements in the array will be 4. First element will be represented using 0, 0 itself, and the second element will be in column major order. Column remains the same but row changes. So here 1, 0 is the second element. The second element will be stored here. Third element will be at we are storing a 2 by 2 matrix. So next element will be from the second column. That is 0, 1. And here you are storing the fourth element, that is 1, 1. Okay. If you want to find the address of this particular element, you can apply this formula. Let the base address be 1000 itself. So the first element will be residing at the memory location 1000. So in order to find the location of the fourth element in this array, you can apply this formula: base address plus j into m. M here represents the number of rows. So j value is 1 here into m's value is 2 plus I value is 1 here, and the size of, let it be an array of integers. Then let us take the size for storing an integer as 2 bytes. Then it will produce the result as 1000 plus 2 into 1, 2 plus 1, 3, 3 into 6, that is 1006. So here you get the address as 1006. So at the memory location 1006, you can store the value a of 1, 1, or the fourth element in the array according to column major order. So this is how you can find the address locations of different elements in the array. So hope you have understood what is multidimensional array, what is two-dimensional array, how to declare and initialize two-dimensional array, and how it is represented in memory. Thank you.